Hello guys, good morning, good day, good evening, good night, wherever you are in the world. I want to welcome you to this edition of Easy Maths Tutor, and my name is Edro John. I promise that I'm going to treat and solve each and every the practical physics questions that we're all expecting in our exams, the likely questions, all right? So we're going to jump right into that right now. So I'm going to use a book and we're going to check through everything. Okay, so this is the book. This is the likely question you're going to find in the book, right? This is the likely question. So it says the title is Momentum, Archimedes Principle and Relative Density. But this particular likely question, practical, is going to be just moment because there is no liquid mass involved. Because there is no liquid mass involved, this part of the experiment is not part of the requirements, okay? So it's just going to be this part, which is a meter rule, a knife edge, masses, and a string. All right, so it says the aim of this experiment is to determine the weight of the meter rule using the moment method. Now the apparatus is the knife edge, graduate meter rule, and some known weights. We're going to leave out the beaker of water because that's not a requirement for the first question. All right, so okay, so we're going to read the instruction. So for the question on resistivity, we have something similar here. All right, we have something similar here. This is the most likely setup, and this particular question, this other part represents the potentiometer. All right, and then the other components of the circuit. All right, so this question is also similar. So we're going to use this question as a basis to solving our electrical or resistivity problem. So now, considering these questions, we're going to look at the theoretical background, the theoretical foundation. So it says, experimental observations have shown that an object will balance freely on a knife, the knife edge. Theoretical foundation. Experimental observations have shown that an object will balance freely on a knife edge called a pivot or a fulcrum when the following conditions are obeyed. Now the first condition, the sum of all clock moments is equal to the sum of all anti-clockwise moments. The second foundation, the sum of all upward forces equal to the sum of all downward forces. Therefore, consider a uniform meter rule whose center of gravity is at the 50 centimeter mark, or whatever mark you're able to measure. If masses M1 and M2 are suspended on the meter rule at a position X and Y from the knife edge, which is placed at the center of gravity, then it will balance freely when mass M1 times X, distance X, is equal to mass M2 times distance Y. Suppose the knife edge is placed some distance away from the center of gravity of the rule with no other mass on the right hand side of the fulcrum. That is, M2 is removed. The balancing relation becomes M1X equal to MOD where MO is the mass of the meter rule and D is the distance between the fulcrum and the center of gravity by the meter rule. Equation 2 shows that a graph of x versus d will give a linear trend with a slope s equal to mo all over m1, from which the mass of the meter rule mo can be deduced. Similarly, experience has shown that when an object is can be deduced. So, from this, we can get our readings, our table of values, and then plot our graph, right? So the procedure. To perform this experiment, we'll use the following steps. The last video I uploaded, I showed us how we can perform this experiment, all right? But I'll just do a quick summary. We'll first of all balance the meter rule freely on the knife edge and record the balance position as G. That's the first procedure. Then the second procedure, you hang a mass MO on a 0.5 centimeter mark. A mark will be given that you are going to keep the mass on, and then we'll adjust the knife edge in such a way that it balances, okay? And then we'll measure and record the distance x, which is the distance from the mass to the center of gravity. So we're going to repeat this experiment when the mass is on the different distances given. In this case, 10, 15, 20, 25, 30, and 35. So we don't know what will be given during the WAEC examination, but you will be given different positions to place your masses. Now suspend the mass MO. Okay, no, we're not going to do this part because this is not part of the requirement, okay? We're not looking for the relative density. We're probably looking for just the mass and the weight of the meter rule. So we're going to tabulate our readings as follows. All right, we're going to tabulate our readings as follows. So the table of values will be P in centimeter, right? X in centimeter. X is the distance from the center of gravity to the position of the mass, okay? In this case, we don't have a y, all right? We don't have a y, but we have a distance that we're going to subtract from the actual center of gravity of the ruler minus the center of gravity of the ruler with the mass, okay? So with this table of values, we're going to plot a graph of x against d, right? We're going to plot a graph of s against d, and then we're going to determine the slope of s, and we're also going to calculate the slopes, all right? And then we'll write our conclusions, and we'll state at least 4 precautions we observed in order to obtain accurate results. And we'll maybe ask some simple questions. For instance, what is moment of a force? And then we may be asked to solve a problem. So this is your graph sheet. You'll be given a graph sheet, right? So you're going to plot the y-axis against the x-axis based on the table of values that you have deduced. All right, so I'm going to draw a table of value. I'm going to draw a table of value where we're going to put our values for our experiment. So we're going to be given okay, so first of all we'll have px this is p in centimeter, this is x in centimeter, right? This is x in centimeter. Then we have, let's say, let me call it d. That is the original distance or the original center of gravity of the ruler, right? Then we're going to have c. C is equal to the difference, right, between, okay, it's going to be the difference between, okay, no, we're going to have y. This is y. Y is the distance of the center of gravity of the ruler with the mass attached to it, all right? With the mass attached to it. Then c is equal to d minus y. D minus y. All right, so this is our table of values. So now we're going to draw up, we're going to be given different distances where we are going to fix our masses. So let's assume we're given the mass of 10 kg, all right, the mass of 10 kg. So we'll find the distance for 5 centimeter. So with a mass of 10 kg, we're going to check the distances for 5 centimeter as given in the question. If it's given, probably 5 centimeter, 10 centimeter, maybe 15 centimeter, 20 centimeter, and 25 centimeter. All right. So x is the distance. So when we balance it, we'll have a distance. All right. So remember that it's the distance of, let's assume this is the ruler. Let's assume this is the meter rule, right? This is the weight of 10 kg. That's what we're assuming. Let's assume this is the knife edge. Okay, this is the original center of the ruler, which is D, at point D. All right, this will be X, the distance from where the weight is and where the ruler balanced. So that's X. This is P. All right, this is X, and this will be Y. This will be Y for 10 kg. So that means we're going to have different tables for different masses. Okay, this is for 10 kg. We'll draw another table. We'll draw another table for, say, 20 kg. 20 kg, P centimeter, X centimeter, Y centimeter, and C, which is equal to D minus Y in centimeter. Okay. It's advisable to draw up this on a rough sheet, okay, so that you don't get your answer sheet rough because of cancellations and mistakes. Okay, so when you do this on your rough sheet, maybe the back of your question paper, then when you're done, you can now transfer it to your answer sheet. Transfer it to your answer sheet. So if we are given 4 masses, that means we're going to have 4 tables. If we have given the number of masses is the number of tables that we will have. Okay, so we'll do the same for 5 centimeter, 10 centimeter, 15 centimeter, 20 centimeter, 25 centimeter. Right? So I was able to formulate these values. This is not the actual values of the experiment. I just was able to formulate some figures so that we'll be able to plot our graph. So we're expected to plot a graph of x against y, right? Expected to plot a graph of x against y. So given these values, we have 15 to 17, we have 10 to 28. So what are we going to do? We'll go to our graph section. This is the graph section. Okay, so now with that particular table of value, we're going to choose a scale. Remember, we want our graph to be 2/3 of the whole graph. So what scale are we going to choose in order for everything to enter into this graph? Okay, so I will choose a scale of 2 centimeters to represent 1 centimeter. 2 centimeters to represent 1 centimeter for the x-axis, and 1 centimeter to represent 1 centimeter for the y-axis. So my method, I am going to cut the graph on the x-axis. I'm going to cut the graph on the x-axis because it's starting from 15. It's starting from 15, right? So I wouldn't want to start from 0 because it's going to take much of the graph. So I will start my x-axis. I'll cut it, right? Because this is going to be 0, but I'm going to cut it at this point and start here from 15. 15, 16, 17, 18, x-axis. That's 2 centimeters to represent 1 centimeter, right? Now for the y-axis, we have a range of 10 to 28, and I promise to use 2 centimeters to represent 10 centimeter. So I'm going to also cut this graph on the y-axis, and I'll start from 10. All right, to be 10, 20, 30, and this will be y-axis. This will be y-axis. To be y-axis. So now the first point we're going to plot on this graph, x against y, is going to be, let's start from the, okay, yes, this is going to be 17 and 28. 17 and 28. So we have 17 and 28. So we have 20 to 30 here, right? So how do we get 28? That means we're going to divide here into 5. And we're going to choose the fourth part as 28, right? So it's going to be 2, 4, 6, 8. That's 22, 24, 26, 28. So we're going to direct 28. Second, give me a second. So we're going to direct 28. This point is 28, right? So we're going to roll it down to 17. We're going to roll it down to 17. So I think this is the point where we have 17. Right? So we've gotten our first point. Then our second is 16.5 and 23. 16.5 and 23. So 16.5 would most likely definitely be the center of 16 and 17. And then 23.5. So we have here 22, 24. So 23.5 has to be this midpoint of 22 and 24, which is the center of this point, right? You know, you really have to be very careful in this part because under exam tension, time, trying to keep to time and all that, you still have to be careful at the same time. This is physics, and if you get this right, you've gotten your A. Then the next point, the third point is 1931. Sorry, it's what 16. The third point is 1619. 1619. So this is 16 and this is 19. And this is 19. Now the fourth point is 15.50 and 14.5. 15.5 and 14.5. 15.5. 15.5 is a midway, and what? Between 15 and 16, you have a midway, right? And 14.5. 14.5, this will be 10, 12, 14, 16, 18, 20. So we need 14.5. So we have 12 and 16. Sorry, 14 and 16. The midway between 14 and 16 is 15. So the midway between 15 and 14 will be 14.5. So that will be somewhere here. You see how you have to be extremely careful. It's not easy, but we can win. And then the last point I have on my table of values is 15 and 10. 15 and 10. So this is 15, this is 10. All right? So now we have our graph. This is our straight line graph. This is our straight line graph. So most definitely we're going to be asked to find the slope of this graph. The slope of a graph is to find the gradient, or the distance, the change in length of the y-axis all over the change in length of the x-axis. All right? So with that, we're going to choose 2 points. I always like to choose the points that are already existing on the table of values. So I'll just quickly choose this point and this point, these 2 points. So we're going to draw the slope line, the slope triangle on those 2 points. Okay, just try to follow me here. Try not to miss me out here. So we will be going back to our plain sheet to get our slope. So to get our slope is equal to the change in the distance in y all over the change in the distance in x. So the distance in y, we chose, remember we chose these 2 points, so it will be 23.5 minus 19.0 all over 16.5 minus 16.0. So if we use our calculator to get these answers right, we'll say 23.5 minus 19. That will give us 4.5. Then we know 16.5 minus 16 is 0.5. So our slope will be 4.5 divided by 0.5. So our slope is a clean 9. Our slope is a clean 9. The slope is a compulsory function that you will be asked to calculate during the examination. So this is how I plotted this graph. So we're going to take a cue from all these ideas to plot every other graph. So I wish you success in your examinations. Stay tuned to Easy Maths Tutor as we bring you more interesting videos. So I guess that was a little bit daunting. Yes, physics practicals are always stressful. At the end of the exam, you need to go and eat very well. You're going to sweat. But at the end of the day, you're going to ace that exam. So I wish you all the best. I know that you can pull this off, okay? So stay tuned to Easy Maths Tutor. Thank you for tuning in. Thank you for coming back all the time. And don't forget to click all the buttons below if you benefited from everything that you learned today. Thank you for watching. See you later. I love you. Lots of love. Bye.